Okay, good afternoon, class.
Good afternoon, sir.
So today we're looking at sequence and series. We just spoke about the proof. We just proved the sum of geometric sequences or series. Okay, so we came with the formula. Sn is equal to A into r to the n minus 1 over r minus 1, and r is never equal to 1, otherwise the sum will be undefined. We also indicated that formula could also be written as Sn is equal to A 1 minus r to the n over 1 minus r. Okay, and what's the difference? Nothing, it's the same thing. When do we use which one? Doesn't matter. Okay. As long as you're not going to make a mistake in substitution, shouldn't make a difference there. People, we're looking at. There's no marker. We're looking at the examples for exercise 6. Exercise 6 on page. Exercise 6 is on page 16. And this is example 1. Example page 15. Alright, so the question says, determine the sum of the first 7 terms in a geometric series 3, 15, 75. So if it's geometric, what's the formula? Sn is equal to A into r to the n minus 1 over r minus 1. So what's your A value? 3. What's your r value? How do I move from one term to the next? Times by 5. Okay, so that's my r value. So let's go, what would it be? 3 into how many terms are we calculating? The sum of the first 7 terms. So it's going to be S 7. So it's 3 into 5 to the exponent 7 minus 1 over 5 minus 1. So it will be 5 to the exponent 7 minus 1 over 5 minus 1. What's 5 minus 1? I could have just written forward. You an answer? 58,593. Okay. Although these numbers seem small, and then we count adding the first 7 terms, going to give you such a massive number. But remember, what's the next number here? It's going to be 75 times 5. 375. I times that by 5. That is the 6th term. There we already in the thousands. Can you see? The 7th term is close to 10,000. The 8th term is 47,000. Can you see? As I indicated, those numbers seem small. Okay, but if you extend it, you'll see these numbers are getting fairly large. Do you guys understand? Any confusion yet? Look at example 2. Example 2. Determine the sum of the terms in the series 5, 10, 20, 40. And the last term is 655,360. So what's the formula that we're going to use for the sum of terms in the series? Sn is equal to A into r n minus 1 over. How do I know it's geometric? Determine the sum of the terms in the series. Did it say geometric? Sorry? Because it has a common ratio. How do I move from one to the next? Times by 2, then times by 2. So this is what makes it geometric. Okay? What's my A value? 5. That's simply 5 into, what's my R value? 2. What's my N? We don't know. Not so. So what do we need to do? We need to solve for N. Not so. Why? Because we got the last term in the sequence. I can actually calculate N. So we let that be Tn. So if Tn is equal to 655,360, what is the general term of a geometric progression? A plus, sorry, not A plus, AR, N minus 1. What's my A value? 5. R, 2. N minus 1 is equal to 655,360. So what do I do now? Divide by 5 both sides. So it's 2 to the n minus 1 is equal to 655,360 must be divided by 5. Gives you 131,072. So what do I do now? Make the bases the same for the exponents to be equal. So please shift. So that must be 2 to some exponent. It's actually 2 to the 17. I'm moving the past. Huh? No. There's 2n minus 1 is equal to 2 to the 17. Now what? The bases are the same? Exponents are equal. So therefore, n minus 1 is equal to 17. So n is equal to? What does that say? There are 18 terms in the sequence, in the series. So it's going to be 5 into 2 to the exponent, 18 minus 1 over 2 minus 1. This is the sum of 18 terms. So what can we do from the? Substitute in the formula and in the calculator. So I got 5 open brackets, 2 to the exponent 18 minus 1 over 2 minus 1. Gives you 1,310,759. That will be your bank balances soon, no? Yeah. All I want is a good computer, laptop. I should be fine. Right, you guys understand?
Yes, sir.
See, any confusion? Something like this probably worth like 5 marks, 4 or 5. No? Can you believe matric is so easy? Right, example 3. Work example 3, and example 3 is on page, sorry, 16. This is for exercise 6 on page 16. Here we are told that the first term of a geometric sequence is 16. What does that mean? Huh? T1, yes? T1 is also what to us? A value is. There's a value. And the sum of the second term and the third term is 12. Sum of the second, so this is going to be T2 and T3 is equal to? The question says determine the sum of the first 10 terms of the sequence. So to go with this information, what do we know? The formula is Sn is equal to A into R n minus 1 over R minus 1. I know n is what? 10. We know A is 16. So what do we need to calculate? R. You guys see that? We need to calculate R. So let's go on the side here. What's the general term of a geometric series? The general term of a geometric series. Tn is equal to AR n minus 1. So what is T2? AR 2 minus 1, which is 1. What is T3? AR 2. You all agree with that? So, with that in mind, if I take this into account now, so this T2 is AR. But what is A? 16. So it's going to be 16R plus T3. What would T3 be? 16R squared is equal to 12. So hang on. What is that? A trinomial is. So 16R squared plus 16R minus 12 is equal to 0. Just wrote it in descending powers of R. So how can I solve that? One of three ways. You can either use your factors in factorization, trinomial factorization, or quadratic formula, yes, or the calculator. For those of you who have the calculator, it is mode, equation, so it's 5, and it's a trinomial, so it's number 3, quadratic equation. Whoops. The coefficient of x squared, which is r squared, is 16 in this case. Coefficient of r, which is b, 16. And the constant is negative 12 and must be equal to 0. Whoops. The answer r works out to be a half, or r works out to be negative 3 over 2. So what does that mean? That means to say there are two different sequences here. Not so. So which one must I use? Both. So if r is equal to half, then S10 is equal to 16 into 12, 10 minus 1 over half minus 1. So let me calculate it. Oops. So I say 16 into half to the exponent 10 minus 1 over, I didn't need that fraction there, that bracket, sorry, minus 1. So if r is half, then the sum of 10 terms is 1 over 2, 3 over 32. You guys understand? On the other hand, if r is negative 3 over 2, your formula would now read S10 is equal to A, which is 16, negative 3 over 2 squared, to the 10 minus 1 over negative 3 over 2 minus 1. Plug that in the calculator. It's 16 into negative 3 over 2. So squared. Negative 3 over 2 is 1.5 minus 1. Gives us, is that correct? Huh? Is negative? $11,605 over 33. You guys understand? Right for homework? I want you guys to do exercise 6. And that's on page 15, 16. Okay. So enjoy the show today. Good morning. Good afternoon, class.